হ্যালো, শুনতে পাচ্ছিস? ক্যান ইউ হিয়ার মি? হ্যালো, ক্যান ইউ হিয়ার মি? প্লিজ কনফার্ম। ওকে, ওকে, ওকে। Good morning, everyone. How are you? How are you? Fine. So, lockdown is extended. So, this is the fourth round of lockdown, and we do not know when we will get rid of it actually. So, what is your feelings? What is your opinion after this fourth phase of lockdown? What do you feel? You cannot see the camera? Wait. Wait, you'll get to see me. Wait. Now you can see me. Yes, now you can see me. Check it once. This is on another chat. I have two IDs logged in. Now you can see me. Okay, okay, very good. No, you just switch. There are two IDs. Devoshnuki, there will be two IDs. One is capital, another one is small. Okay, so the one which is in small letter, it is you can see me what there. Right? If you want to listen to me, you just click another ID. You switch my chat. You switch the chat. You switch. Yes, everything can be seen. You switch the chat. There are two IDs logged in. Can you check? Now, yes. Now you can see me. You cannot see me. So what to do? Wait. Oh, wait a second. The Zoom is actually hanged. That is why. Wait. Now you can see me.
No, sir.
Still you cannot see me.
Sir, video is not on.
Wait.
না স্যার দেখতে পাওয়া যাচ্ছে না
Wait. Now you can see me.
Yes, sir.
Yes, sir.
Okay. Sorry for the disturbance. Actually, what happened? The Zoom software that is running on my computer was got hanged. Actually, that is why. Okay. So, however, we are about to start machines, as I said.
হ্যাঁ স্যার
Okay.
ডবল শুনতে পাচ্ছি স্যার।
স্যার ইকো হচ্ছে কেন
হ্যাঁ, ওটাই তো।
Wait.
ভাই ইকো হচ্ছে, আমার এখানে তো হচ্ছে না ইকো।
Sorry for the interruption. Now the echo will be clear. Now there will be no echo. Is it okay right now? Oh, after lots of disturbance, now you are ready. Okay. So last day, what we have discussed, we have completed one chapter, and you cannot see the whiteboard. You can see the whiteboard. You switch. Okay. So last day, what we have studied the second chapter. Okay. And I have told that today I will be discussing about the third chapter, that is machines. So this chapter is very important for your ICSE examination, because every year few questions come, and this chapter is most important for numericals as well. Okay, you will get to see that pulleys are there, simple machines are there. Okay, so every year you some questions you have to solve from the theory part as well as from the numerical part. So what you have to do, you have to solve, you have to read out the entire theory portion, basically few definitions. Most of the theory part is definition. Okay, and then there will be some formula, and then we have to solve some numericals. So basically our course of study will be divided into three parts: theory part, that means the definition part; formula part, that means the concept part; and then the third one, that is the numerical part, or you can say application part. Okay, so we will divide our course of study in these three part. So as I said, the name of the chapter is machine, and this is the first class. So my name is Devoshinaki, you all know. Okay, so first, it is for the internet speed, it is the for the problem of the internet speed. Maybe my internet is also not good actually, so that is why maybe it is the problem. So please wait. Yes, yes, so maybe for the internet speed, that is why you are getting problem. Okay, so first of all, functions of a simple machine. So what are the functions of a simple machine? Let us understand this. So in lifting a heavy load by applying less effort. Okay, so what does it mean? Sometimes what we have to do, we have to apply less amount of force, and we have to convert that effort into to lift heavy amount of load. So this is something that, sorry, so so this is the load, this is the effort. Sometimes what we have to do, we have to apply less amount of force to lift the huge amount of load. So this application of the device is called force multiplier. Now there is another application, that is in changing the point of application of the effort to a convenient point. So sometimes you get to see that there are lots of cases where you cannot directly apply a force to lift a body. So what you have to do in that case, you have to you have to change the point of application of the force. So this point, changing of the point of application of the force, is called in that case we apply simple machine. So to change the convenient point, so we choose the point at our convenient point. Okay, so there are few simple machine, we'll get to see the example. Another one is the directions, also changing the direction of the effort of the convenient direction. So let me give an example, so that then in that case it will be easy for you to understand. Suppose यहाँ पे কুয়া है, কুয়ো, ঠিক আছে, পাত কুয়ো থাকে না, পাত কুয়ো। তো এখানে একটা এরকম লাগানো থাকে, ছোটোবেলায় সবাই এঁকেছিস, হ্যাঁ আমিও অনেকবার এঁকেছি। এখানে একটা কি থাকে, পুলি টাইপের থাকে, আর এখান থেকে এদিকে ফোর্সটা অ্যাপ্লাই করা হয়, সো দ্যাট জলটা এদিক থেকে, জলের বালতি থাকে এখানে, কুয়ো, জলের বালতি, আমি খুব খারাপ আঁকছি আমি জানি, দেখে মনে হচ্ছে না, যাই হোক। তো এখানে জলের বালতি থাকে, জলের বালতিটাকে তোলা হয়। সো this is the mass, so I am applying a force, and that is why I am applying the force over here. That is why the force is actually applied in the opposite direction, and then I can leave the object. So this is something. So what we are doing over here, if you get to see, try to understand later, you will try to understand the purpose of doing this only is to change the direction. I want to here the force is applied in the upward direction, I want to change in the downward direction. So maybe sometimes you have to change to upward to downward, sometimes upward downward to upward. So there are lots of cases where I need to change the direction of in my convenient direction. So here if you see, when we want to lift water from the well, so I have to apply a force. It is better if I get to apply the force in the downward direction. Okay, because যদি আমরা নিচে থেকে এরকম করে জল তুলতে চাই, কি হবে, পড়ে যেতে পারি নিচের দিকে, হ্যাঁ ঝুঁকে পড়ে যদি জলটা তুলতে চাই কুয়ো থেকে, পড়ে যেতে পারি। তার থেকে যদি ওপর থেকে এরকম করে যদি টানা হয়, তাহলে কি হবে, ইট উইল বি কনভিনিয়েন্ট ফর আস to take out water from the well. So that is why we apply this kind of things. Okay, another one is a very good example. This is obtaining obtaining is obtaining is no, it's not. So it is a printing mistake. So it is obtaining a greater speed. Okay, obtaining a greater speed. Obtaining a greater speed. Okay, so there is a typing mistake. So the means obtaining a greater speed means sometimes what we have to do, we have to increase the force. We have to increase the speed of our doing work. Okay, so sometimes we need to increase the force, sometimes we need to increase the speed. So in that case where we want to increase the speed, there are another kind of examples where you can get to see that we are, by applying a simple machine, we are actually trying to obtain a greater speed. Okay, so these are the three causes. These are the three causes where these are the functions and uses of a simple machine. These are the causes where we need to apply simple machines. Okay, and there are lots of examples of simple machine, and we'll try to understand them and try to understand for which purpose it is used. Either I'll get to see that that is the definition of machine. Okay, that is the definition of machine. What is the definition of machine? Let's read it out. A machine is a device by which we can either overcome a large resistive force. So what is the first cause? As I said, either we can overcome a large resistive force at some point by applying small force at a convenient point. Okay, this convenient point is important, and a desirable direction, or by which we can obtain a greater speed. Obtain a greater speed. There is a typing mistake. Obtain a greater speed. Okay, so I am reading once again. What is simple machine? What is machine? Machine is a device by which either to overcome a large resistive force at some point by applying a small force at a convenient point in a desired direction. Okay, so four points are important. As I said, to overcome a large resistive force at some point, applying a small force in a convenient direction and in a desired direction, and or, so this is a first case, or by which we can obtain a greater speed. So these are the four applications. This can be the definition of a simple machines. So this definition is also important. Please try to understand. This definition is also important. Try to memorize this. Okay, next, load. So as I said, we will be learning few definition. Okay, why this is important? Because in order to understand the entire chapter, entire concept, if you do not know what is A, what is B, what is A, what is B, what is C, if you do not know how to learn these, how to read them, can you read a single letter? No. So similarly, if you want to read this chapter properly, you need to understand the what is load, what is effort, because in the following few seconds or few minutes, we will be reading, we will be telling load, effort, load, effort, load, effort, many and many times, thousands times I will tell load is applied over here, effort is applied over here. So it is very important for you to understand what is load. If you do not know what is load, then how will solve the numerical? So that is why let's try to understand what is load. The resistive force or opposing force to be overcome by a machine is called load. That means there are few cases where there is a resistive force or opposing force. Opposing force what? Opposing force against of which we have to apply the force. So this resistive force or opposing force is called load. Okay, I hope this is clear. Now effort. What is effort? The definition of effort can be the force applied on the machine to overcome the load is called effort. Okay, so this part is really important, on the machine. Okay, so effort is applied over where effort is applied on the machine. Okay, the force applied on the machine to overcome the load is called effort. Okay, and here also by a machine. What is load? Load is always applied by a machine and effort is applied on the machine. These are the two major difference of effort and load. Load is by the machine, effort is on the machine. Okay. Now let us try to understand mechanical advantage. What is mechanical advantage, and why we try to understand mechanical advantage always. Okay. So I can say mechanical advantage equal to, it is basically the ratio between the load and effort. Okay, it is basically the ratio between load and effort. So this is load and this is effort. Okay, so how we can define mechanical advantage? Mechanical advantage, the ratio, what they are telling, the ratio of the load to the effort is called mechanical advantage of the machine. That means if I try to, now it is clear to me what is load. Load is the force which is applied by the machine. What is effort? Effort is the force that is applied on the machine. So if I try to calculate a ratio between them, if I try to find out what is the ratio of load to the effort, what we will get to see? We will get to see that we are getting mechanical advantage. Okay. Now you can say, what if I ask what is the unit of mechanical advantage, what will be the answer? Anyone out there, please unmute and answer. Ishita, tell. No unit. Why it have no unit? Ishita, tell. It's a ratio. Yes. If we try to figure out, or if we try to find out the ratio between two similar product, two similar quantities, then there will be no unit. So that is why mechanical advantage do not have any unit. Okay, but although it do not have any unit, but there is some physical significance or meaning of mechanical advantage. So what we get to see, what we understand when I say it's a mechanical advantage. So it tells when mechanical advantage is greater than 1, the machine work as a force multiplier. Okay, now here comes another question, what is force multiplier? Okay, we will try to understand this. Okay, now what is force multiplier? Tell. Yes, see, try to understand. If this is the situation, load by effort greater than 1, so it tells when mechanical advantage is greater than 1, so that means load by effort greater than 1. So what we can write? Load is greater than effort. This is quite happen because if mechanical advantage is greater than 1, then load must be greater than effort. Load must be greater than effort. So that means by applying a smaller amount of effort, we are able to lift a greater amount of load. So this point is clear. By applying a smaller amount of effort, we are able to lift a greater amount of load. So here load is greater, effort is smaller. So that is why we can tell that this is working as a force multiplier. So force multiplier is something where we can get this. Okay, next one, when mechanical advantage is less than 1, the machine work as a speed multiplier. Okay, now what is the definition of speed multiplier? Why it is speed multiplier? Yes, so here see, obviously this relation is opposite, so it is for it was for force multiplier. Now let me draw the same thing for speed multiplier. For speed multiplier, this will be the relation, because for speed multiplier obviously mechanical advantage is greater than lesser than 1, so that means load by effort lesser than 1. As I said, if the mechanical advantage is less than 1, so less than 1, that means load is less than the effort. Load is less than the effort. So what we can conclude from here? So here you have to apply a greater amount of force in order to lift a small amount of load. So this point is clear that in case of a speed multiplier, you have to apply a greater amount of force. A greater amount of force is needed in order to lift a small amount of load. But here comes a question, that why we need to do this? That is because here our target is not to apply a smaller amount of force, rather our target is to increase the speed of work. Try to understand. There are few causes. So in case of a speed multiplier, our target is not to apply a small amount of force, rather our target is to we can afford to apply a greater amount of force, but we cannot afford to do the work in a smaller speed. So that is why in order to do this we use speed multiplier. Okay, and another interesting point, if when the mechanical advantage is equal to 1, okay, it can neither work as a force multiplier nor as a speed multiplier. Okay, so अगर इक्वल हो जाए, যদি জিরো হয়ে যায়, সরি যদি ইকুয়াল টু 1 হয়ে যায়, গ্রেটার দ্যান 1 হলে ফোর্স মাল্টিপ্লায়ার, লেসার দ্যান 1 হলে স্পিড মাল্টিপ্লায়ার, ইকুয়াল টু 1 হলে নাইদার ইটস আ ফোর্স মাল্টিপ্লায়ার নট ইটস আ স্পিড মাল্টিপ্লায়ার। তো কিছুই নয়, ফোর্স মাল্টিপ্লায়ার হিসেবেও কাজ করবে না, স্পিড মাল্টিপ্লায়ার হিসেবেও কাজ করবে না, তাহলে কাজটা কি করবে? সো ইন দ্যাট কেস, so we have read 4 points. Okay, see, we have read 4 points. So this was 1, this was 1, this was 2, this was 3, this was 4. So if this is happening, it's a force multiplier. If this is happening, it's a speed multiplier. But rest of the 2 are already also left. That means to change the direction and to change the application of the point. So if the mechanical advantage, if you get to see that if the mechanical advantage is equal to 1, then these are the things left for the simple machine. So it can only change the direction of the force or the point of application of the effort. So we can only change the direction of the force or the effort. So that is something very easy for us to understand. So I hope this is clear. If this is not clear, please let me know. Please unmute yourself and let me know. Is that clear? Aheli, Bhumika, Aryan, is that clear? Okay, okay, okay. Yes, tell. I cannot hear your voice clearly. There is so much sound. Is my voice is clear to all of you? Okay, okay. What you are telling? Continue, please. Gaurav, it was right? Gaurav, what was your doubt? Please tell me. Aryan, tell. So, no, see, if the mechanical advantage, as I said, if the mechanical advantage is less than 1, then we have to apply a greater amount of effort to lift a less amount of load. So that means here a greater amount of force is needed in order to lift a smaller amount of load. So in that case we have to afford a source of force which can apply a greater amount of force to lift a smaller amount of load. But there is a point that here I can do the work in shorter time. So here I am just increasing the speed. So that is the application when the mechanical advantage is less than 1. So afterward there are lots of examples. If this part is not clear to you, the theory portion, when you are solving numericals, and after it will understand, you'll understand this. Now let us understand what is velocity ratio. What is velocity ratio? Okay. Another thing I forgot to mention, mechanical advantage is represented as m dot a dot, okay, and velocity ratio is represented as v dot r dot, okay. The ratio of the velocity of effort to the velocity of the load is called velocity ratio. So what we can write, velocity ratio equal to velocity of effort, okay, by velocity of the load. So this ratio is called velocity ratio, okay. Now let us try to understand. It can also be defined as the ratio of the displacement of the effort to the displacement of the load. Now let us try to understand how we can do this. Now what is the definition of velocity? Who can tell me what is the definition of velocity? Velocity means displacement by time, okay, displacement per unit time. So can I write velocity of the effort as VE? So this is VE, okay, and velocity of the load is VL, okay. So velocity of the effort equal to displacement of the effort by time, okay, and velocity of the load equal to dl by time. Can I write this? If I can, please confirm. Okay, so velocity, so dE, what is dE? Displacement of the effort, and what is dl? dl is the displacement of the load. So I can simply cancel the t, and what I have only, I have dE by dl. So this is quite yes, dE by dl. So that is the velocity ratio. So what is the if I ask what is the alternative definition of velocity ratio? So the alternative definition of velocity ratio is the displacement of the effort, the ratio of the, it can be also defined as the ratio of the displacement of the effort to the displacement of the load. Okay, now here also, what if I ask what is the, Somjit, please tell me what is the meaning, so what is the unit of this velocity ratio? It have any unit or not? Somjit, please answer my question. কেন থাকবে না বলতো, কেন থাকবে না? Yes, very good. So it is the ratio of two similar quantities, that is why it have no unit. Now but there are physical significance also. If the velocity ratio is less than 1, the mechanical the machine work as a speed multiplier. So if velocity ratio is less than 1, so what does it mean? It means that dE by dl less than 1. So it means dE is less than dl, okay. So that means if the velocity ratio is less than 1, then displacement of the effort by displacement of load is less than 1. That means displacement of the effort is less than the displacement of the load, okay. Displacement of the effort is less than the displacement of the load. So in that case I can tell yes. So in that case I can confirm that yes, I can lift a huge load, I can lift the load with a greater distance, displacement of the load is greater with a, when we are applying the small amount of displacement for the effort. So that is why velocity ratio is less than 1, the machine work as a speed multiplier. Is that part is clear to everyone? Please confirm. Aryan, Aryan, unmute yourself. Is that clear, Aryan? Okay, okay. Now the velocity ratio is greater than 1. In which case it will be greater than 1. So if the velocity ratio is greater than 1, the machine work as a force multiplier. Okay, here also if the displacement is small, then force is greater. So in that case it work as a force multiplier, and same thing for the, if the velocity ratio is equal to 1, it will only change the direction of the force. Okay, if equal to 1, it will only change the direction of the force. So these are the thing we get to see. So the common thing about mechanical advantage and velocity ratio is, in both the cases, if it is less than 1 speed multiplier, if greater than 1 force multiplier, equal to 1, nothing happens if it work as a direction to change the direction of the force. এই রে কি করে কাট হলো রে, কি করে কাট হয়েছে? হোয়াটসঅ্যাপে বলেছে নাকি? ও যাই হোক, ঠিক আছে, কি আর করা যাবে। অনেক জায়গায় ইন্টারনেট শাটডাউন আছে, চন্দননগরে ইন্টারনেট শাটডাউন আছে, তোদের ওপারে কয়েক জায়গায় ইন্টারনেট শাটডাউন আছে। কি যে হচ্ছে না দুনিয়াতে, কি বলবো। চন্দননগরে ইন্টারনেট শাটডাউন আছে। যাক, উইল নট ডিসকাস about all these things. Okay, now unit. Okay, tell. In unit time, where? See, if you are telling the ratio of the velocity of effort to the velocity of the load, it's called velocity ratio. You don't have to mention unit time. Okay, but if you are trying to define, it is called the it can be also the alternative definition. It can also be defined as the ratio of the displacement of effort to the displacement of the load in a time, in unit time. In that case, it is better to mention about the time or in same time, because if here T1 and T2 must be equal, both the T must be equal. So in the alternate definition, it can also be defined as the ratio of the displacement of the effort to the displacement of the load in same time or in specific time. It is better to mention, but in the first case it is not mandatory to mention. Okay, is that clear? Okay, okay. Now units in both the case, both the mechanical advantage and velocity ratio do not have any unit, because they are the ratios of similar quantities. I think this is clear. Now work input, let us discuss about work input. Now what is work input? Work input, basically it is the work that is done on the machine, okay, by the effort. Please try to understand this. The work done on the machine by the effort is called work done. I am reading once again. The work done on the machine by the effort is called work input. Okay, so here this is few point is important. On the machine, okay, on the machine. So what is work input? Work input is always done on the machine. By whom? By the effort. Okay, so these 2 points are very important. ওকে, সো এর মানেটা কি? এর মানেটা দাঁড়াচ্ছে যে আমি যদি একটা ওয়ার্ক করতে চাই কোনো একটা সিম্পল মেশিনকে কাজে লাগিয়ে, আমি সেই সিম্পল মেশিনের ওপর যতটা ওয়ার্ক করছি, আমি অ্যাজ এ পারসন সিম্পল মেশিনের ওপর যতটা ওয়ার্ক করছি, সেটাকে বলা হচ্ছে ওয়ার্ক ইনপুট। মানে আমি যতটা ওয়ার্ক দিচ্ছি, দ্যাট ইজ কল্ড ওয়ার্ক ইনপুট। ওকে, সো হোয়াট আই ক্যান রাইট, ওয়ার্ক ইনপুট ইকুয়াল টু effort multiplied with displacement of the effort. Displacement of effort. Okay, now this part is not clear to him. Please tell me, I'll explain to us. Explain it again. Effort into displacement of the effort. Work input equal to effort into displacement. How we are getting this? আমরা কি করে এটা পাচ্ছি? আমরা কি করে এটা পাচ্ছি? আচ্ছা কৃতি নেই না, কৃতি is absent in the class. Hello. Okay, Sumit, answer this question. Sumit, unmute. हाँ Sumit Pandey. আনমিট করছে না। আচ্ছা তুই তাহলে বল, প্রজ্ঞান বুঝতে পারিসনি? কোনটা বুঝতে পারিস? এটা বুঝতে পারিসনি? ওয়ার্ক, আচ্ছা এটা দেখ, আচ্ছা এদিকে দেখ, আমরা কি জানি ফোর্স ইকুয়াল টু, সরি সরি আমরা কি জানি, হোয়াট ইউ নো দ্যাট work done equal to force into displacement. Okay, this part is all clear. This এটা তো কারো ডাউট থাকে না, work done equal to force into displacement. Now এখানে work done কি, here work done is work input, so this is work input. Okay, now here what is the force? Here the force is effort. Okay, and here what is displacement? Here the displacement is the displacement of the effort, isn't it? Displacement of the effort. So that is why we are getting this relation, work input equal to effort into displacement of effort. So what I can write, work here in the abbreviation, in the short form we will write this work input equal to effort, that is E into DE. Yes, effort into DE. What is effort? What is E? E is effort, and what is DE? DE is basically the displacement of the effort, and E is the effort. Okay, this part is clear. Yes, tell. Repeat your question once again. No, I'll discuss it about when we'll discuss about lever. After explaining this, we'll discuss about the lever. Then you'll get to see. Okay. Now, work done. Let us understand work done. The work done by the machine on the load is called work output. Okay. So here the question is, what is work output? Work done by the machine. So here it is by the machine. Okay. Very important. Here the work is done by the machine on the load. So here if I am applying the force, and for that reason the work is done, so here the work is done by the machine, and on which the work is done? On the load. The work is done. Who is doing the work? The machine is doing the work. So work output means work done by the machine on the load is called work output. So similarly, what you can Hello, Arkadeep, can you listen to me? Hello, Arkadeep. Hello. Yes, is that okay? Okay. Okay. Now, work output equal to you can see, wait video, wait, দেখা যাবে দেখ দেখ বুড়ো মানুষ একটু ভুল, হ্যাঁ বুড়ো মানুষ একটু ভুল ত্রুটি করতে পারি, হ্যাঁ মাঝে মাঝে একটু ইয়ে কর। যাই হোক, এবার দেখতে পাচ্ছিস? হ্যাঁ তোকে দেখতে পাচ্ছি, হ্যাঁ ভালো আছি, ভালো দেখা যাচ্ছে, ঠিক আছে। শ্রীদীপ কি হয়েছিল রে, তোর ইলেকট্রিসিটি চলে গেছিল শ্রীদীপ? ওকে ওকে, ইয়েস, খুব ভালো কথা। আচ্ছা, লিসেন টু মি নাও। ওয়ার্ক আউটপুট, হোয়াট ইজ ওয়ার্ক আউটপুট? ওয়ার্ক ডান বাই দ্য মেশিন on the load is called work output. So let us try to understand this. Okay, so we can write work output equal to, what we can write, work done, sorry, it will be load into displacement of the load arm, okay, so load into displacement of the load. So similarly, like the previous case, if what is work output? Work done by the machine on the load, okay, that is called work output. So here I can write it in the form load into displacement of the load, that is dl. Okay, is that clear? Can I move on to next? Okay, now efficiency. Now here another comes a very important parameter, that is called efficiency. How much efficient it is? Efficiency means how much efficient it is to do my work. So what I can write, that the efficiency of a machine is the ratio of the work done on the load by the machine to the work done on the machine by the effort. আমি এটাকে একটু ভালো করে সহজ বাংলায় বুঝিয়ে বলছি। এর মানে কি, আমি কতটা পাচ্ছি কতটা দেওয়াতে। ওকে, লাইক আমি এখন এতটা এফোর্ট করছি তোদেরকে বোঝাবার, সবাই কি একদম 100% আমি কি অ্যাপ্রুভ করতে পারি যে আমি যতটা এফোর্ট করছি, যা কিছু এই ভিডিওতে বলাচ্ছি পুরোটাই কি 100% তোরা বুঝে যাবি? ইট ইজ ইম্পসিবল। ফার্স্ট অফ অল আমরা একটা ইন্টারনেটের মাধ্যমে পড়ছি এখন, তাই না? আর দ্বিতীয়ত ইট ইজ ইম্পসিবল একটা ভিডিও লেকচার বা যে কোনো একটা ক্লাসরুম লেকচারে বা ক্লাসরুম সিচুয়েশানেও ইট ইজ ইম্পসিবল ফর আ টিচার দ্যাট এটা অ্যাপ্রুভ করা যে সবাই একদম 100% বুঝে যাবে, তাই না? তাহলে তো সবাই 100 পেয়ে যাবে, তাই না? সো দ্যাট ইজ সামথিং কল্ড ইম্পসিবল। সো হোয়াট ইজ এফিসিয়েন্সি? এফিসিয়েন্সি মিনস work output, yes, work output work output by work input. So efficiency means that means আমি কতটা work পাচ্ছি by আমি কতটা work দিচ্ছি. So basically it's a ratio between output by input. ওকে, আমি কততে কত পাচ্ছি. ওকে, সো আমি তার মানে কি পরীক্ষায় যেমন ধরো না 10-এ বা 100-তে বলা গেল 80, এটার মানে কি আউট অফ 100 হি ইজ গেটিং 80. তার মানে কি আমি 100 নাম্বার ওকে দিয়েছিলাম, তার মধ্যেও 80 নাম্বার পজিটিভ আনসার করেছে বা ঠিক আনসার করেছে, দ্যাট মিনস 80/100. তেমনি আউটপুট বাই ইনপুট, সো এফিসিয়েন্সি মিনস কি হচ্ছে ওয়ার্ক আউটপুট বাই ওয়ার্ক ইনপুট. দ্যাট মিনস আমি কতটা ইনপুট দিয়েছি বাই ও আমাকে কতটা আউটপুট দিয়েছে, এই রেশিওটাকে বলা হচ্ছে এফিসিয়েন্সি. ইজ দ্যাট ক্লিয়ার? এইবার এটাকে জেনারেলি এফিসিয়েন্সিকে জেনারেলি আমরা পার্সেন্টেজে ডিনোট করি. ওকে, পার্সেন্টেজে আমরা এটাকে ডিনোট করি. ওকে, নাও আমরা এই এফিসিয়েন্সি সম্পর্কে একটু পরে আরও ডিটেলে ডিসকাশন করছি. এর আগে আরও কিছু ইম্পর্টেন্ট প্রিন্সিপাল আছে, সেগুলো একটু পড়ে নিই. প্রিন্সিপাল অফ আ মেশিন, প্রিন্সিপাল অফ আ মেশিন, সিম্পল মেশিন কি বলছে? বলছে দ্য ইনপুট এনার্জি ইকুয়াল টু দ্য, ফার্স্ট অফ অল ইনপুট এনার্জি কি, ওয়ার্ক ডান বাই দ্য এফর্ট, এটা আমরা অলরেডি পড়েছি. দ্যাট মিনস এফর্ট ইন্টু ডিসপ্লেসমেন্ট অফ দ্য পয়েন্ট অফ অ্যাপ্লিকেশন অফ দ্য এফর্ট. ওকে, দিস পয়েন্ট ইজ ক্লিয়ার. Now output energy, what is output energy? By work output equal to work obtained at the load, that is equal to load into displacement of the point at a point of application of the load. This part is also clear. Okay, this part is clear or you have doubt, please confirm, then I will tell the principle. This part is clear, Somjit, this part is clear? Okay, so what you can write for the principle of a machine is output equal to input energy. Okay, output equal to input energy, but with a condition for an ideal machine, for the ideal case. Okay, now here comes the question that what is, Somjit, please mute yourself. What, okay, those who have not muted, please mute yourself. What is an, Who is Oppo? ये Oppo वाले कौन है? Oppo के रे? Okay, what is an ideal machine? MACHINE. এই আইডিয়াল মেশিনটা কি? আইডিয়াল মেশিন মানে কি? এটা কোয়েশ্চেন, মানে তার মানে কি কে? আচ্ছা, কি বলছি? হ্যাঁ বল 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 অর্কদীপ বল. বল. Okay, so first thing that I can comment about ideal machine, very good. The first thing that I can comment about the ideal machine is efficiency of an ideal machine is 100%. Efficiency of an ideal machine is 100%, but here comes another question, that is there any other kind of machine? Okay, so first let us learn these things. What is an ideal machine? As I said, an ideal machine is that in which no loss of energy in any manner. That means no loss of energy, as I said. And the second point, that is that Orkodip said, that the efficiency of an ideal machine is 100%. Next, what is an actual machine? The opposite of ideal machine. Okay, in actual machine, what will be what we expect the efficiency? Efficiency is less than 100%, isn't it? And in an actual machine, the output energy is always less than the input energy. So isn't that mean that efficiency is less than 100%? Can anyone help me to understand this? Who can help me to understand this? Srideep? Srideep is here. Srideep? Yes, help me to understand what is actual. 16 জন মাত্র. Okay, I'll talk about this. Okay, now there is a, now second point, there is some loss of energy during this operation. Obviously there is some loss of energy. As I said, in an actual machine, work output is always less than the input energy. Okay, now next point, the moving part in it is neither weightless nor smooth. Okay, that means what does it tell? That it tells that there is a friction. There is a friction. Another point, if there is a string or perfectly elastic body, so if there is a string, it is not perfectly elastic. So generally what we expect, that in case of a string, if it is perfectly elastic, then there is no loss of energy, but if it is not perfectly elastic, then there is loss of energy. So in case of this actual machine, the strings are not perfectly elastic. And another point to lose the energy, the defined part of energy is it is not perfectly rigid. Okay, so these are the point. It is not perfectly elastic, perfectly rigid. So there are different reasons for which the energy is lost. Okay, and why the energy is lost? The most prominent loss of energy is to overcoming the force of friction between the moving part and the machine. Okay, this is an interesting point. No matter how you are working the machine, it is still impossible to get something which is giving me 100% efficient. So ideal means ideal, we cannot reach the ideal case. So practically it is not possible to get a machine which is giving you 100% energy. That is because of the friction. In every cases, wherever you go, friction is always there. So that is why a reasonable amount of energy is lost in form of heat at least or sound. So this is why in case of actual machine, the output energy is always less than the input energy. Okay, the output energy is always less than the input energy. Yes, what happens with it? Tell. From 10 a.m. you have the class. Okay, let me just explain this, then I'll release the class. Okay, next question. If a machine is 80% 80% efficient, what does it mean? If I tell, what does it imply? Okay, it implies that 80% of the energy is used as useful energy. That means work output and 20% of energy is as a form of heat or other form of energy. That means frictional energy, we can tell frictional work done, or I can tell heat simply. Okay, friction. Okay, so work input equal to work output plus the energy. So what you can tell, that 100%, if 100% is the work input, then work input equal to work output plus the heat energy or frictional energy that is being wasted. Okay, so 80% is useful energy. So these are the things. The point of lever is left. Okay, so and the relationship between the sorry, হ্যাঁ ওটাকে আমি করেছি তো, LIVER লিভার মজা করে। ওকে, স্পেলিং ইজ LEVER। ওকে, LIVER নয়, লিভার নয়। ওকে, সো এটা আমি ইচ্ছে করেই করি, এটা প্রিন্টিং মিস্টেক নয়, ইচ্ছে করে মিস্টেক। আচ্ছা, যাই হোক, তাহলে পরের দিন আমরা এই রিলেশনশিপটা পড়বো, রিলেশনশিপ বিটুইন এফিসিয়েন্সি অফ মেকানিক্যাল এনার্জি, মেকানিক্যাল অ্যাডভান্টেজ অ্যান্ড ভেলোসিটি রেশিও রিলেশনশিপ, এবং বাদবাকি আরও অনেক কিছু জানার চেষ্টা করব। বেসিক্যালি দ্য রিলেশন ইজ mechanical advantage equal to velocity ratio into the efficiency. So this relation we have to prove in the next class. Okay, আজকে তো 10টা হয়ে গেছে, তোদের ক্লাস আছে আবার, ঠিক আছে তো? সো ওকে, গো ক্যারি অন। কি ক্লাস আছে এখন? হিন্দি ক্লাস। ওকে, গো অ্যান্ড কন্টিনিউ উইথ ইউর হিন্দি ক্লাস। হ্যাঁ, দেখে নি, সবাইকে দেখি, চলো, যে দেখাতে চাইছো। হ্যাঁ, আচ্ছা, ঠিক আছে, দেখেছি। আর হ্যাঁ দেখতে পাচ্ছি ঈশিতা, হাই ঈশিতা। আর কে আছে দেখি? সোমজিৎ, হাই সোমজিৎ। শ্রীদীপ, হাই শ্রীদীপ। আর কে আছে? আর কে আছে দেখি? সবাই ভালো থাকো, হ্যাঁ, ভালো করে পড়াশোনা করো। হুম, হাই সীতা। আচ্ছা ঠিক আছে, চলো সোমজিৎ, সবাই ভালো থাকো, ঠিক আছে? ঠিক আছে, ঠিক আছে, ঠিক আছে, টাটা। না, এইসব এনিডেক্স ইউজ করবে না, হ্যাঁ, এইসব এনিডেক্স ইউজ করবে না। হ্যাঁ, এনিডেক্স ইউজ করবে না, বাই। হুম 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 হুম।